Hi all, welcome to this, the first new video looking at the lithosphere topic. And in this video we're going to be looking at glacial depositional landforms. Now before we get started, I want a quick apology from me. This video was meant to go up earlier than now, so apologies on my end. And also there are two review videos which will be going up as soon as I can physically get them up. And they're going to be looking at general processes associated with the lithosphere topic and the glacial erosional landforms that we've already discussed. But without further ado, let's get into the glacial depositional landforms. So first, a hit list, a feature list. Now, when we talk about glacial depositional landforms, we can split them into a couple of categories. You've got ones that are, very literally formed by glaciers. And even at that, one of the three, till/boulder clay, drumlins and moraine, you can make a bit of an argument that there's some Floovio glacial stuff involved there. And then we've got a series of features that are formed by fluvial glacial processes. Now, what do we mean by that term, fluvial glacial? With that, we're talking about features that are formed by the virtue of water that's been created by glaciers, so glacial meltwater. To go through the kind of full list, they say we've got till/boulder clay. Now I've put both words in there because they do get used kind of interchangeably. I will try to refer to boulder clay as much as possible, but you'll need to forgive me if occasionally I flick between the two. We've got drumlins, we've got moraines. Now you'll notice that's moraines plural, as there is more than one type of moraine that we'll discuss today. We then have outwash plains, kettle holes, eskers, kames and kame terraces. Now that is, it's a reasonably long list of features, but don't worry about it. Most of them, the formations, if we want to call it that, are pretty short and to the point. So let's get started and let's actually get into this. So first, what is boulder clay? Now boulder clay as a thing is actually really straightforward. Boulder clay is the kind of catch-all term that we use to talk about deposits, as in sediment deposits, that we find underneath glaciers. So we call them subglacial deposits. Now they're really more defined by their characteristics than any particular formation. Their formation is they were deposited by a glacier, but their characteristics are quite telling. One, they are almost entirely unsorted. So we don't see, for instance, if you've got a river, we would expect to see larger, more angular pieces in the upper course, and we would expect to trend towards smaller, more well-rounded material in the lower course. You don't see any form of sorting with boulder clay. If you look at the image that's on screen, you kind of get the idea of what I'm talking about. Everything in that image, from the tiniest, pieces of clay, grains of sand, up to that kind of big, huge boulder, all form part of boulder clay. It's entirely unstratified. Now, by unstratified, we are talking about it's not layered in any significant way. Again, if we looked at sediment that was deposited in lakes or in ocean environments, it builds up in layers. Now, we don't see that in this case. This material is dumped. It is just dropped and there's no particular ordering of the sediment. And last, most, kind of quote unquote, most of the material that we find as part of boulder clay is quite angular. Now, the important bit there is we can tell that that means that this material has not seen much, if any, fluvial action. There's not been much, if any, rivers actually working on this material, transporting it, eroding it, and actually, wearing it down from its quite angular condition. Now, next, drumlins. Now, drumlins are a bit odd in that there is actually a little bit of argument about how drumlins are formed. We're going to talk about one particular version of creating drumlins, but as a little bit of a health warning, if you're looking into this a bit more, you will find other discussions on the formation of drumlins. But what we're going to talk about here is accurate, and it's also what we would take forward into the exam. So first, what is a drumlin? It's a large hillock. Now, by hillock we mean it's an uplifted area of land, but it's not as big as a hill. So we're talking about something that's going to be 10 metres or so high. Mainly composed of till, and that's me making a mistake, not a mistake, but me making a slip there, or boulder clay. Sometimes they've got quite a rocky kind of solid core, sometimes they're made entirely of boulder clay. And the creation here is we're talking about glaciers depositing large volumes of boulder clay during periods where you've got catastrophic subglacial flooding. So periods where the glaciers are retreating, where they're melting, and they are releasing huge volumes of water all at the same time. Now, during that process, a lot of material is going to be getting deposited, particularly larger chunks of material, especially if you've got this rocky core, you've got this item, this piece of the landscape that the water is having to flow around, and it's going to drop a lot of material there. Now, the water is also then going to shape the material as it flows, and it's going to shape it around whatever obstruction happens to have formed. Now, the glacier, or the kind of the upstream side, is always the steep end of a drumlin. And then as you go downstream away from where the glaciers would have originated, it shallows off. If we do have drumlins in groups, which is really common, we refer to them as swarms. And you get this, you can see it in the diagram. If I take me away, you can see that this is referred to as a basket of eggs topography. Now, the next thing that we've got here, if we look, we've got moraine. Now, as I say, we've got moraines, plural. Now, the reason we say that is we talk about three main types of moraine. Now, we've got terminal moraine, which is probably the easiest one to understand, as in it's terminal, as in the terminus of the glacier, where the glacier made it to its maximum extent. And what that is, if you imagine a glacier moving down a valley, it's going to have a little kind of bundle of material that the snout of the glacier is bulldozing ahead. When the glacier eventually goes back, it's going to leave that little bundle of material at the area it made it to furthest, and that's your terminal moraine. Now, lateral and medial moraines are oddly similar, and the diagram that I've got coming up next explains them a little bit better than I can do talking about it. These are ridges of material that are found either at the side of glacial valleys or running down the middle of them. It's formed from material that would fall off the sides of a valley on top of a glacier when it's flowing downstream. And when the glacier melts, this material drops onto the valley floor and is deposited there. If I get two glaciers that meet, then two bits of lateral moraine are going to join, and they're going to form a medial moraine on the new larger glacier that's formed. A last bit of throwing in here now, technically speaking, not a piece of moraine, but it does link in quite neatly with it. You get glacial erratics. Now, I say they are similar to moraine, but different in that it is one big lump of material. It's one big lump of rock, and it's characterised by being found in an area that's well out with where you would expect to find it normally. Now, very, very briefly, looking at this, you can see the kind of thing. There's a lot of information here that we can talk about in class. But if we look at, you've got lateral moraine here, then this would be forming all the way along this side. And again, you've got it forming down this side as well, and down this side. But here I've got my place where my two glaciers meet. And where they meet, I get a medial moraine that forms down the middle. I've got my terminal moraine down at the front, and this is the maximum point that the glacier made it to. Now, jumping into this different set of features, this little subset that we call Floovio glacial features. First, an outwash plain. Now, an outwash plain is a large-scale proglacial feature. Now, what I mean by that is by proglacial, it's ahead of the glacier. It's in front of it. And this is basically a huge area where you've got lots of different processes happening that are basically river processes. But all of those rivers are being fed from the glacier itself. So, you'll find large amount of meltwater, you'll find large amounts of deposits off the back of this, and most of the streams that you would see as part of an outwash plain will be much larger than any kind of natural stream would be in this region, because they've got such a large source of water that they can use as in the glacier that's melting. Now, one of the things that we get in the outwash plain, now it's worth noting actually, at this point, that the following features can all form as part of outwash plains. They all form inside an outwash plain. The last two can form a little further up, but they can all form in an outwash plain. First, kettle holes. Now, one of the things that's really common when a glacier is retreating, when it's melting, is that it doesn't just, it's not like an ice cube where it just melts very kind of gradually. Bits will break off the front, there'll be glacial collapses, quite dramatic stuff can happen. Now, when that does, or if you do get a bit of glacial collapse and you get a big chunk of ice that falls into the ground, if that then, let's say we get a small period of glacial advance immediately after that, which is really common to get glaciers retreating and advancing and retreating and advancing as temperatures change. So if my glacier is retreating and it drops a big chunk of ice, then it advances back over where that chunk of ice was and deposits boulder clay on top. My chunk of ice is now buried in the ground. Over time, the glacier retreats all the way back and it just vanishes up the valley and it's totally gone. I've still got that chunk of ice that's kind of insulated in the ground, so it's going to stay there for a little while. It will eventually, of course, melt, and when it does, it creates a void, it creates a hole under the ground. Now that hole is going to mean that the boulder clay above it is going to sink, and it's either just going to form a depression, a big dip in the ground, or if the water level there is high enough, it could form a little loch-in. Next, ESCOs. Now ESCOs are really cool, but very weird in that you need to accept that underneath glaciers you get rivers that flow, which can seem really odd when you think glaciers, big lump of frozen water, yet through it or under it you can have flowing water, but you can. So if we accept that, where ESCOs are formed, they are formed by these subglacial rivers which cut a channel through the glacier and then they fill it with material that they're transporting. Now these form really well sorted, well layered features that are very, very linear. They form nice snaking straight lines, and they can be 10, 15 metres high and 10 or more kilometres in length. They are really quite kind of striking features. Kames. Now kames are a little bit odd in that you can get kames and you can get kame terraces, which are kind of merged into one thing here, and it's the last feature we're going to look at. So if we've got a period where glaciers are melting, it's common for the glacier to be moving backwards, 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 and then stop. And it just kind of sits there for a little while and it doesn't do a huge amount. When it's stopped, we still have processes going on. One of those processes that we can have is meltwater streams and little loch-ins can be forming on top of the glacier. If it's a meltwater stream, it's going to form on top of the glacier and we're going to have flowing water, and it's going to hit the edge of the glacier. Where it hits the edge of the glacier, it forms a small delta. Now, we've not went into hugely what deltas are, but all you need to know is that it's a fan-shaped area where you've got lots of deposited material. And that's going to form and it's going to build up and build up and build up, and eventually my glacier is going to stop being stagnant and it's going to keep moving backwards. Now that little bit of material, that delta that had built up, forms a little mound of sand and gravel, and it's like a little tiny little hill. And that's a kame, that little mound. Now, if on the other hand I don't have a meltwater stream, I've got a small loch-in. Now that small loch-in is equally going to gradually fill up with sand and gravel. Now that can create a much bigger area where we've got a big layer of sand and gravel which can form a big ledge or a big terrace at the side of the valley after the glacier has retreated. Now, I'm going to wind this one up here. I'm going to put this little diagram up, and it gives us an idea of what we're talking about with some of these Floovio glacial features. So if we look here, if we start with kind of our ESCOs, so if we've got, nice consistent ESCOs, it's making little comments here about its little disturbed stratification or much disturbed stratification, that's kind of more getting at whether or not the glacier or rivers or some other process after the fact has disturbed this feature. But you can see how, this is my outwash plain, and my glacier was way up here somewhere. It's left with this little kind of linear hill that goes all the way down it, and that's my esker. My kames are these kind of much, much smaller little hills that form in here, and my kame terrace is this much larger area. And yet sometimes, as it says here, these can collapse, so very frequently at the edges they'll collapse because they're not being supported, and they are made up of sands and gravels. Now, this has been a lot of information in a very, very short period of time. Once again, apologies for this one going up a little late, guys. Obviously, we will discuss this during next lesson, and you'll have an opportunity to talk about these with me, and we'll have an opportunity to look at different kind of texts and stuff as well. Keep your eyes open for the next couple of videos. As I say, they will be the two review videos, so overall lithospheric processes and looking at glacial erosional landforms. And until next time, I'll see you guys later.